Okay, so here's the question we are going to be working with. A common pool shot involves hitting a ball into a pocket from an angle. Shown below, the cue ball hits a stationary ball at an angle of 45 degrees, such that it goes into the corner pocket with a speed of 2 meters per second. Both balls have a mass of 0.5 kilograms, and the cue ball is traveling at 4 meters per second before the collision. Recall that the collision is elastic. Calculate the angle with which the cue is defected by the collision. Okay, so let's start with seeing what we all have. So we have the mass of the cue ball, which was said to be 0.5 kilometers. And then we also have the mass of the second ball, so we just put M2, which was the same. And then we have the velocity at the beginning, so I'm putting an O for that of the cue ball, which was said to be 4 meters per second. And then we also have the velocity initial of the second ball, which is 0 meters per second, since it was said to be stationary, so it's not moving. And then we also have the velocity final of the cue ball, which was said to be 2 meters per second right there. Now we don't have the velocity final of the second ball. And then we also do not have the theta of the second ball. So we don't know what that is, but we do know what the other one was. So I'll put theta q, which is 45 degrees. Okay, so we have two things that we do not know, but we are trying to find the theta for the second ball. Maybe put a 2 here. Okay, so now looking at this equation, we can see that it is a collision in 2 dimensions because it collides once it hits the second ball. But we can see that it's 2 dimensions since they aren't just keep going in the x direction. They also end up going into the y direction. So that's why it's collision in 2 dimensions. So when we solve for this, normally if it was just in one direction, we would just use one equation, but since it's in 2 directions, we have to use one for the y values and one for the x values. So we'll start with the x values. So the equation we use for this is the same that we would use for if it was just a collision in 1 dimension. We just use it twice, like I think I said that already, but since they aren't sticking, we use M1 VO1 plus M2 VO2 is equal to M1 V1 plus M2 and V2. Okay. So now what we can start with is the mass of the first one. So that was 0.5 kilometers. And then that's times the velocity. Now for the velocity, since it's the x, we have to use 0.4, which is moving in the x direction. So we can use this. So we use 4 meters per second plus 0.5 kilometers or kilograms. And this one was 0 since the ball was not moving before the collision. And remember that this part of the first half before the equal sign of the equation is everything before the collision happens. And then after the equal sign is everything after the collision. Okay. Then it's equal to the mass of the first, so 0.5 kilograms. And then the velocity after the collision, remember this is after, so that was 2 meters per second. And then we also have to add in the angle, so that's cos of 45, because we're dealing with this kind of triangle right here. And now we use cos because when we are using x, that is going in this direction here. So we have to use, which would be adjacent over top of hypotenuse, which is cos. Because we are not using opposite, we cannot use sin. We have to use cos. Okay. And then plus the other mass. And then we don't have this velocity, so we will just put VF2. And then again, we have to put in the cos. And we were putting in these cos since it is in 2 dimensions. We need to use them. Oh, sorry, not 45. We don't know what this is. That's for the other one. So this is just cos theta because we don't know what it is. Okay, and then we'll try and start shortening this up. So 0.5 times 4 is 2. And then 0.5 times 0 is 0, so we'll cross this out and we won't put anything there. Then 0.5 times 2 times cos of 45 is equal to 0.707. And then plus, and then we cannot do anything with this quite yet because there's only one number in it. So we will just leave it as it is. Okay. Now, next we can see that we can take out the 0.707 and move it to where the 2 is. So 2 minus 707 is equal to 1.293. And then again, we can't do anything yet with this one, so we will leave it as it is for one more. Okay, so now we can take out the 0.5. So we will divide this by 0.5 and divide this side by 0.5. So this here, 1.293 divided by 0.5 is equal to 2.586. And then we have left, we can cancel these two out, and this is equal to VF2 cos theta. So now we can't really do too much else with this, but we can once we get the y value, so we will do that. Maybe make that into a better x. Okay, so then let's see what we can get for y. So we'll take the exact same equation that we used for x and use it again for y. Like I said before, we need to use it twice since it's 2 dimensions. Okay. So remember that y, when we do the y values, it has to be everything in the y direction. So it has to be everything going this way, up and down. So we will start, and we have the mass of the first ball, which was 0.5. And then the velocity is equal to 0 meters per second. Because remember what I said, that with the y values, we can only go up and down. So the 4 meters per second here for the first ball is going in the x direction. It's going this way. So we can't use it because it isn't going in any, like it isn't going in the y direction. So we have to use 0. And then plus 0.5 kilograms. And then the velocity again is 0 because it was said that it was not moving. So it's 0 again. Just like for x, it was. And now 0.5 kilometers for the mass of the first one. And then again, we have the velocity of the first, which was 2 meters per second. And now we can use sin 45. Instead of using cos like we did for x, we can use sin because y goes up and down. So in our little triangle we have here, I'll just draw it out a little bit. The little triangle we have here for y, we are using opposite and hypotenuse. So opposite over top of hypotenuse is sin. So that's why we need to use sin for the y. Okay, and then plus the other mass of the ball. The other ball is 0.5. And then again, we do not know what this velocity is, so we will leave it as VF2. And this time we use theta. Because remember, this one here again is opposite over top of hypotenuse because we are going up and down. So we have the opposite value now that we have to use. So we have to use sin. Okay, and then we will try and start solving again. So now this side is completely 0 because 0.5 times 0 is 0, and again 0.5 times 0 is 0. So the first half is just 0, and then 0.5 times 2 times sin of 45 is equal to 0.707. And plus, and then again we can't do anything yet with this one, so we will have to leave it just as it is. Okay. So now again we can see that we can move the 0.707 over to where the 0 is. So it equals to minus 0.707. And we have to leave this again as it is for one more step. Now we can take out the 0.5. We can take it out of this side, and then we can take it out of this side. Now, minus 0.707 divided by 0.5 is equal to minus 1.414. And then on this other side, these two are just canceled out, and we are left with the velocity final of the second ball times by sin theta. Okay. So now all we have left to do, since we have some values here, is to again find out what this theta is. So now when we look at what it is a triangle. And this is what we were trying to find, is this here. Now, this might be a little tricky to see, but the y is this here. It is equal to the velocity final and sin, but it is a y value. So we can use it here as the y, and then we can use x as this here. Because remember, x here is going this way, and y is going this way. So now to find what this is, we can recall that tan is equal to opposite over top of adjacent. So we can see that we can put y over top of x. And then our y value is the minus 1.414. And the x value is 2.586. So we will fill that in. Okay, so now since we have some numbers that we can put into our equation to actually find the theta, we can solve. So this here is all equal to minus 28.67 degrees. So we know that this is right because the theta here is going in the downward angle, so that means that it has to be negative, which it is. But this isn't totally our answer yet because we need to do sig figs. So we have to have 30 degrees because of our sig figs. Now, it is going in the negative direction, so you can put a minus 30, or you could just write 30 degrees going in the negative direction. And this is our answer.